the tangent as a limiting case of a secant. Welcome, everyone. Let's begin today's lesson. Now, in our previous session, we established the fundamental definition of a tangent. We described it as a straight line that touches a circle at exactly one single point. However, today we are going to move beyond just knowing what a tangent is, and instead, we are going to explore the deeper relationship between a secant and a tangent. You see, in geometry, a tangent isn't just a completely separate, isolated entity. Rather, we can view a tangent as the limiting case of a secant. This means that if we observe how a secant behaves as it moves, we can actually see it transform into a tangent. Over the next few slides, we will break down exactly how this transition happens. Understanding the starting point, the secant. Now, before we dive into the actual transition from a secant to a tangent, let's take a moment to refresh our memory on what a secant actually is. Think back to our basic definitions. A secant is simply a straight line that cuts through a circle, intersecting it at exactly two distinct points. Now, if you look at the part of that line that lies inside the circle, specifically, the line segment that connects those 2 points of intersection, we call that a chord of the circle. To make this more concrete, let's visualize a specific example. Imagine we have a circle with its center labeled as O now. Let's draw a secant line through this circle so that it hits the edge at 2 points, which we will call P and Q in this scenario. The line segment connecting P and Q is our chord. Keep this image of the 2 points, P and Q, firmly in your mind, because in the next slide, we're going to see what happens as we move this line to transform it into a tangent. The process of transition. Now that we have recalled what a secant is, specifically that line passing through points P and Q, let's move on to the most important part of today's lesson, the transition itself. I want you to visualize how a secant actually transforms into a tangent. Imagine that secant line we just discussed, and picture it moving gradually away from the center of the circle while always remaining a perfectly straight line. To make this clear, let's break this movement down into 5 simple steps. First, let's look at our initial position. At the start, our secant line cuts through the circle, intersecting it at 2 distinct points, which we've labeled as P and Q because the line is closer to the center. The distance between P and Q, which is the length of the chord, is relatively large. Second, let's introduce movement. As we slide that line further away from the center, which we call point O, watch closely what happens to those intersection points. As the line moves outward, the points P and Q begin to migrate along the circumference of the circle, moving closer and closer to each other. Third, notice the effect on the chord. As these 2 points, P and Q, move closer together, the length of the chord, PQ, is steadily decreasing. The gap between them is shrinking. Fourth, we reach what we call the limiting point. If we continue this movement, we eventually reach a specific position where the 2 points, P and Q, no longer exist as separate entities. They coincide or merge into one single, solitary point. Finally, we see the result. At the exact moment that P and Q become one single point, the nature of the line changes. It no longer cuts through the interior of the circle. Instead, it merely touches the edge. At this precise limit, the secant has officially transformed into a tangent. To help you see this in a more practical, everyday context, let's look at the next slide, where I'll use the analogy of a sliding ruler. Real-world analogy, the sliding ruler. Now, I know that the mathematical movement of points $P and $Q we just discussed in the previous slide might feel a bit abstract. So, to help you visualize this transition more clearly, let's step away from the geometry textbook for a moment and look at a real-world analogy using objects you might find in your kitchen or classroom. Imagine you have a circular plate sitting on a flat table, and you have a long, straight ruler. This is our setup. First, take that ruler and lay it across the plate so that it actually cuts through the middle of the plate, crossing over the edge at 2 different spots. If you look closely at this position, you'll notice that the ruler is currently acting exactly like the secant line we defined earlier. It enters the circle at one point and exits at another. Now, here is where the magic happens. I want you to imagine slowly sliding that ruler away from the center of the plate, making sure the ruler stays perfectly straight as you move it. As you slide it, pay close attention to the 2 points where the ruler overlaps the edge of the plate. You will observe that the distance between these 2 points is getting smaller and smaller. The chord is shrinking. Keep sliding the ruler further and further toward the edge. Eventually, you will reach a precise moment where the ruler is no longer crossing through the plate at all, but is instead just barely grazing or touching the very edge of the plate. At this exact instant, the ruler is touching the circle at only one single point. Just like we saw in our mathematical breakdown, the ruler has now transformed from a secant into a tangent. This physical movement perfectly demonstrates the concept of a limiting case that we will summarize in our final slides. Key takeaways. First, let's keep the fundamental distinction clear in our minds. A secant is a line that intersects a circle at 2 distinct points, whereas a tangent is a line that intersects the circle at exactly 1 point. Second, remember the process of movement we just studied. As those 2 intersection points of a secant move closer and closer together along the circumference, essentially making the length of the chord approach 0, the secant eventually transforms into a tangent at the moment those 2 points coincide. Finally, this brings us to that crucial term, the limiting case. We call the tangent the limiting case of a secant because it represents the precise boundary or the final state of that movement. It is the exact moment where the line stops being a secant and begins to be a tangent. All right, let's bring everything we've discussed so far together. We've looked at the definitions, we've visualized the movement of the line, and we even used the ruler analogy to see the transition in action. Now, let's summarize the key takeaways from this lesson. Now, before we wrap up, I want to point out a few common pitfalls where students often lose marks, so please pay close attention to the next slide. Common mistakes to avoid. First, be careful not to confuse a secant with a tangent. It might sound simple, but remember the fundamental difference we discussed in our first few slides. A secant must, by definition, intersect the circle at exactly 2 distinct points. If you find that your line is only touching the circle at a single point, you are no longer looking at a secant. You have reached the tangent. Second, pay close attention to the term limiting case. A common misunderstanding is the idea that the line suddenly jumps from one state to another. As we explored with the sliding ruler analogy, this is actually a continuous, smooth process. There is no sudden leap. Instead, imagine the 2 points of intersection, P and Q, moving closer and closer together. The distance between P and Q approaches 0, that is, the length of the segment PQ tends toward 0. It is this continuous movement towards 0 distance that defines the limit. Finally, do not confuse the chord with the secant itself. While they are closely related, they are not the same thing. As we noted in our second slide, the chord is specifically the finite line segment located inside the circle, bounded by the 2 intersection points. The secant, however, refers to the entire infinite line that passes through those points and extends beyond the circle. Now, before we conclude our lesson, I want to pause and address some common pitfalls. As we have seen throughout this presentation, the transition from a secant to a tangent is a subtle one, and it is easy to get tripped up by a few specific details. Keep these distinctions in mind, and you will have a much firmer grasp of the relationship between these 2 geometric lines.